So hello everyone, and welcome to our archaeological approach to cobalt exploration brown bag session. My name is Adela Payne, and I will be your host for today. Firstly, I would like to acknowledge that SCWIST does its work for Canadians from the traditional, ancestral, and unceded territory of the Squamish and Musqueam nations. This acknowledgement is a reminder of the discriminatory, racist, and colonial practices that have had a lasting legacy and continue to create barriers for Indigenous people and communities in our city. In the next few days, I encourage you all to learn a bit more about the land we live on and personalize your connection to the territories on which we have settled. So without further ado, I would like to present today's speaker, Helen Thompson. Helen Thompson is a PhD student at the University of Sheffield in the UK, researching colonial and indigenous ceramics in Argentina and in Chile. She completed her undergrad degree at McGill University, studying a double major in art history and in anthropology with a minor in East Asian studies. While her expertise lies in petrographic analysis of ceramics, she is particularly passionate about tracing geological source materials, understanding how objects move, and dissecting the technologies of the past. So I will now open the floor for Helen to give us her presentation.
Hi everyone. I hope you're all doing well today. I'm in England right now, so it's 8 p.m. for me, so I hope you're all having a nice lunch break. Yeah, I guess I'll just get right into it. So I do study colonial and indigenous ceramics in Argentina and Chile, but today I'm going to talk to you about something completely different. Yeah, so today's presentation is about cobalt exploration and how an archaeological approach could help us find more cobalt sources, or if that's possible, essentially. Yeah, as much as I love petrography and petrographic analysis of ceramics, my biggest interest is in the exploitation of materials and raw materials and how they're transformed, and what the study of cultural artifacts can tell us about human nature and the past and essentially the present, to be so bold. So yeah, I'll just get right into it. Go next slide. There we go. So when a lot of people think of cobalt, this is what comes to mind. This is on the right, we have a picture of a geological cobalt ore. And on the left, we have a picture of a lithium-ion battery. So there's been a massive surge in cobalt in recent years because of lithium-ion batteries. It's become very important for the green economy. It's huge for all of our phone batteries have cobalt in them, electric car batteries. Yeah, the most efficient batteries these days have cobalt metal in them, but there's a global shortage predicted for cobalt by 2025. They're struggling to find new sources, or new sources that are viable, particularly given that the main source as of now is in the Democratic Republic of Congo, and there's lots of issues there with child mining, illegal mining, and various things. So there's a need to find more sources. I first heard a talk about that in December 2019, and being an archaeologist, all I could think about the whole talk was how cobalt's been valuable for thousands of years to cultures around the world for a very different reason. So when I see cobalt or think of cobalt, I think of this. This is a early Roman glass blue bowl, and it's colored with cobalt, and that's what creates the deep blue color in the bowl. So yeah, this is what made cobalt significant to people for thousands of years. And what's so amazing about it is that it's been important since, you know, the kind of 14th century BC in Egypt until 16th century AD in China, and been used for various different reasons. So there's lots of evidence of cobalt as an archaeological source in the past. It's considered a holy grail for archaeologists because of how many artifacts it's been in. It can shed light on how ancient cultures move, how things are traded, how things are exploited. And archaeology is a really good way to kind of put the pieces of the puzzle together, in my opinion. It studies the physical past, from human remains to plant and animal remains and subsistence patterns to artifacts. So you can kind of piece together a whole image of what our past looked like. And archaeological studies can help us shed light on time periods that are pre-text records, and they can also help give us physical evidence for time periods in which there are text records. Though sometimes historians don't appreciate that, because sometimes physical evidence can, you know, change what they've written in textbooks or various things. Cobalt is particularly special because it's, as I said, it's ranged from kind of 14th century BC to 16th century AD, all that stuff. That's fantastic. And there's been lots of archaeological studies trying to trace the origins of cobalt in artifacts. Yeah, I'll touch on that. This I wanted to talk about quickly first is an example of that. So this is probably the most famous shipwreck in the archaeological community. It dates to the 14th century BC, and it's called the Ulumburan shipwreck. It's found off the Mediterranean coast, and it was full of these blue glass ingots. So it had lots of other artifacts on it that were being traded as well, but they found thousands of these, essentially. And these are, an ingot is kind of a semi-melted glass, so that it could be traded and remelted and made into other glass artifacts in other places. And the shipwreck that they found was full of them, and they are all colored with cobalt blue. So there's this indication that cobalt was valuable, and it was being traded widely, kind of throughout the Mediterranean at least, possibly further afield. And that really kind of sparked the interest in cobalt studies in archaeology. So cobalt's a cross-craft material as well, which is also what makes it so important. You can find it in various different artifacts. I'll give you a brief rundown for some background information on each of them. This is glass. Glass is probably one of the main things that archaeologists study when it comes to cobalt. It's an inorganic material. It's interesting because it has the physical characteristics of a solid, but it actually has the atomic characteristics of a liquid, which means it can be remelted, recycled, and reused, which partially makes it difficult for tracing the origin of artifacts because sometimes, yeah, things have been remelted. This is faience. Faience is really interesting. It's kind of a precursor to glass. So it's a quartz body with an alkaline glaze. So it's not ceramic and it's not glass, but it's kind of an in-between precursor to both of them. And that was used, especially in Egypt, to make beads around mummies' necks and tombs, and they often colored that with cobalt blue as well. And then we have ceramics, which are pretty well known. This is a Chinese blue and whiteware. The distinct blue color comes from cobalt as a pigmentation, and so those are pretty famous and personally a personal favorite of mine. I love them. And then I just have two examples here of cobalt used as a pigment as well. So we have an ancient Egyptian wall painting here, and then we actually have a Van Gogh painting, which he was one of the first painters to use cobalt as a pigment, which I find interesting. It was actually considered cheaper when he started using it than other pigments, despite its value kind of for thousands of years throughout different cultures. So bringing it back, how does archaeology help us find ancient cobalt sources? How can we relate that to the global shortage of cobalt today? So artifacts can be subjected to chemical testing to reveal their compositional anatomy. Typically, chemical analyses cannot reveal geographical locations for raw material sources unless previous testing of mineral deposits has taken place. So most often, chemical testing is used for grouping. Artifacts with the same compositional anatomy can be assumed to have been produced from the same mineral source, essentially. So you can put them into groups as to they all would have come from the same place. But unless you've tested the mineral deposit beforehand, it can be hard to say it's definitely come from this place. But once you've done that, once you've kind of put them into groups, that data can be cross-referenced with archaeological evidence of trade, text if there are any describing source locations, any geological data from surrounding areas where artifacts were found, if that data does exist. Although if artifacts are obtained through trade, that does get more complicated. But essentially, you can test for the data, get the chemical compositions, group them, and then cross-reference with all the archaeological evidence that you have and go from there. So throughout that whole process, you can determine the consumption and production sites of artifacts, and ideally raw material sources as well, hopefully. These types of investigations can help determine broad regions where cobalt may have come from, or in some cases with local geological survey, you might even be able to pinpoint the specific spot where it came from. Yeah, so for this specific project, I spent a few months working on this in the summer, and I looked into 4 kind of case studies, and I was trying to determine are these places that could be viable for present day cobalt exploration? Could they be geological sources we could use now? And does archaeological research that already exists out there, does that work to find cobalt sources? So I looked at 4 places or 4 studies, which were the Bonus Aventus plaque, which I'll go through next, glass and faience from the Western Oases in Egypt, glass axes from Nippur, which is in Iran, and glass beads from Madagascar. So I went through each of them. And so the Bonus Aventus plaque is right here at the top on the right. This is really interesting just as an artifact separate of cobalt, because for ages people thought that it was a Roman glass piece. It's not. It's a medieval replica, which I find really interesting. It's basically a fake, but a medieval fake, which is a whole separate side note, but very interesting. So it was long believed to be a Roman artifact. They conducted chemical analysis on the artifact and discovered that there was 3.2% cobalt oxide, and various associated oxides, but the one I want to draw attention to is arsenic. So there was 6.3% arsenic oxide, which is considered quite high, particularly for Roman artifacts. You don't find Roman artifacts that have such high levels of oxide in them. Additionally, so to color an artifact deep blue, you only need about 0.5% cobalt oxide. So this is considered really high as well, 3.2%. And it closely represents more of a composition for smalt, which is essentially the medieval version of an ingot. So it's a semi-melted glass. It was used for trade widely. It was actually even used to trade all the way to China. Yeah, so when they tested this artifact, these oxides really stood out in their percentages, and they started to realize that, hold up, this isn't Roman, this isn't what we thought it was. So they compared it with smalt, and they compared it with other things from the medieval time, and discovered that it matches an ore source from Erzgebirge in Germany, which is just here on the map. So this is a really good example of pre-existing geological data, and they were able to compare the tests and discover that the source did come from Germany. So they were able to figure out, 1, that it was medieval and not Roman, which is interesting, but 2, they found the actual source material for cobalt. There's lots of text evidence for this time period as well. So Erzgebirge is a well-known mine. They mined silver there as well, which is all pretty interesting. And as a bit of a side note, Erzgebirge in Germany in general is actually where the name cobalt comes from originally, because miners, when they were smelting the metals, the high levels of oxide or arsenic that they were getting was creating a toxic gas for them, and they thought that that was a demon coming to get them, named Cobalt. So that turned into the name cobalt, the oxide, etc., which is pretty interesting. So Erzgebirge in Germany was the first source material that we kind of went through with the case studies. The second one was glass and faience from the Western Oases in Egypt. So this was 15th to 14th centuries BC. It was really common to use cobalt to color things blue. We've got some glass here up in the top. These are all from the site of Amarna, which is way up further north, not from down here. It's the site where the production is actually found is up north in Egypt. So yeah, there was 2 well-known workshops. There was Amarna and there was a place called Makelta, and they mass-produced deep blue glass artifacts during the 15th to 14th centuries BC. Significant chemical analysis has been undertaken on glass from those workshops, and researchers confirmed that they believe the sources come from these oases down here. So this source material is really interesting because it's a cobaltiferous alum, which basically means, so an alum it's a hydrated double sulfite of aluminum and sometimes potassium. So it's a secondary alteration product, which basically means that the glassmakers at the time would have been taking bits of this alum source to color their artifacts blue, but they weren't taking cobalt ore. They hadn't actually found the cobalt ore source itself. So what's really interesting about this is that there could likely be a much larger source material in the area that hasn't actually been found yet. And what's been found is kind of the runoff, the alteration product, etc. So this case study was really interesting to look at because there's a lot of options here for further research. In Nippur, so there's hundreds of deep blue glass shards from glass axes that were found at an archaeological excavation, and those date to the 14th to 13th century BC. it's not the best quality photo here, but archaeologists kind of believe these artifacts to be the best representation of lapis lazuli, which is a really precious blue stone. And at the time that was considered highly, highly valuable. And there's a lot of theories that people were recreating that look by using cobalt and glass, and that they were trying to kind of imitate the precious stone for a cheaper price. These are believed to be the best representation of that. So the cobalt source for these axes was initially believed to be well-known Egyptian sources that I just spoke about in the Western oases, but chemical analysis quickly revealed that they didn't match. So there's down here, you can kind of see in Nippur, this is the chemical makeup of the trace element assemblage, which is the group of elements that make up the coloring. So this has cobalt, iron, etc. And this is the Western oases, and it's a completely different list of elements. So they quickly realized there's a whole new source material out there from this time period that we didn't know about. The project on the glass axes alone wasn't able to identify a source material. They had a few theories. So there's a mine called the Kashan mine in Iran, which is well known for producing cobalt, particularly for a type of ceramic called Abbasid wares, which was the 13th to 14th centuries AD. But that's 13th to 14th centuries AD. These glass axes are from BC. So the likelihood that that mine was being used is pretty low. It's a pretty weak argument, in my opinion. So that theory, yeah, they've tested it as well. There's not a great match there. So on the other hand, there's a strong possibility that the cobalt is actually from the eastern regions of Egypt. So I've highlighted the eastern part of Egypt here. And what's really interesting about this case study is this kind of, to me, shows the intersections of kind of the scientific analysis and the archaeological research and other evidence, and how you can kind of combine the two together. So if you look on the map up here of Iran, this is Nippur where the axes were found. This is Nimrud at the top. So Nimrud predates Nippur. It's a little bit older, and there's really good evidence that they had a direct trade route with the eastern regions of Egypt, and that they had cobalt artifacts from Egypt as well. So Nippur, being younger, doesn't have this, well, it doesn't have the same written evidence that has been found, but culture and geography indicate that the trade route could have existed at the same time, and that it did continue to exist. Plus, there was, well, it's a bit of a longer story, but there was a dip in production from the previous cobalt in Egypt, and it basically disappeared for several centuries, and then it came back later on, but it didn't come back. The artifacts that came back don't match the Western oases. So there's a lot of arguments that there's a source on the eastern side of Egypt that archaeologists haven't found yet that was providing cobalt for Nippur for the axes, possibly for Nimrud and trade objects, and for later period Egyptian cobalt blue artifacts as well. That was a bit of a long one, but there's a lot of evidence for that, and I find it really interesting. So the fourth case study is glass beads from Madagascar. So in the top picture here, you can see there's not great examples, but there's some cobalt blue beads there, and there, and there, and there. They're just little small ones. So glass beads can be found on archaeological sites all across the continent of Africa. They're probably considered the most common type of glass artifact found in Africa, South Asia, and Southeast Asia. A group of archaeologists excavated the large assemblage of beads from two sites in Madagascar, which is the Mahilaka site and the Sandrakesti site, and they tested them for their chemical composition. So the blue beads were, they wanted to attempt to understand their composition and the source of the glass and the cobalt. The ratio of cobalt to arsenic is the primary thing that they decided to examine to kind of decide what type of ore it would be, etc. And it was found that the majority of the beads were colored with cobaltite. So that's quite important, because cobaltite is high in arsenic. As mentioned before with the Erzgebirge stuff, that connects to that mine, but that's a medieval mine. And Roman artifacts that were cobalt blue had very low arsenic. So old things, old artifacts from this time period, it's rare that things were colored with cobaltite because arsenic is toxic when you smelt it, and that makes things really complicated. So there's two theories for the source of the cobalt of the glass in Madagascar. The first one, the only thing they know for sure is that the glass beads weren't produced in Madagascar itself. There's no evidence for any kilns or melting sites at the archaeological sites themselves. The evidence indicates that the beads were traded or at most remelted on site, that the glass wasn't produced itself in Madagascar. So they ruled out looking at sources in Madagascar. So what is unclear is if it arrived as big ingots that they then melted down, or if it was as beads themselves. However, typologically, these beads are almost identical to beads found across South Asia, and particularly in India and in the region around Khetri, which is in northern India. So archaeologists investigating the beads examined India more closely as a possibility and discovered that historical and archaeological documentation of cobaltite existed in the mining region of Khetri up here. So they had lots of cobaltite. It was quite well known. And what's really interesting about Khetri is that it's a current present day operational copper mine. And it's been active for over 2,000 years as a copper mine. So there's a lot of questions there as to why they're not mining the cobaltite if it is there. But anyway, so the archaeologists then tested the ratios of cobalt to arsenic versus the cobaltite ores from Khetri, and they found them to be a pretty near match. So Madagascar was getting their cobalt beads most likely from Khetri in India. So this is just a world map to show you guys kind of where everything lies in relation to each other and where it sits in the world. We've got the sources of in Germany, Egypt, Khetri, and then these are the archaeological sites, and Madagascar down here. And there's also an interesting discussion to be had about sites in China. I'll come back to that later, but it should be part of the conversation at some point. So, are these sources viable? Short answer is yes. The long answer is it's complicated. And there's other locations to consider. So this is my little chart that I made with my little emojis. This is the easiest way to explain. We don't know. It's a bit unclear. So first of all, go through Erzgebirge. Being an active mine through the medieval and post-medieval period, the site is well documented and known by geologists today. There may already be cobalt there to be exploited, but it could already be on the radar, or it does not necessarily bring anything new to the table that people aren't aware of already. Mostly the site served as a great starting point for examining how these case studies could work. And despite that, it is important to note that there's few heritage concerns, and Germany is considered a politically stable country and an easy place to conduct mineralogical exploration. So it kind of checks those boxes, but it is already kind of known to geologists. In the Western oases, it's a little more complicated. It's not known to geologists. What I mean by that is the cobaltiferous alums there have been found by geologists, but the larger source material has not. So as a secondary alteration product, it'd be quite cool to find the origin source, and it's quite likely that there is a bigger source nearby. So that's a good thing, I suppose, for exploration. The problem is, about 5 years ago, the Dakhla and Karga oasis regions were actually closed off to tourists because of unrest foreigners in the region. The travel ban's actually been lifted pretty recently, but it's unclear as to how stable the region is for mining exploration and if that would be viable. Most importantly, there is major heritage concerns at these oases. So at Karga in particular, it's kind of a valley kind of area. And when you come into the valley, it's littered with pottery and ancient shaft mines. And there's lots going on there. So it's quite a heritage site. And that would be, if you found the bigger source and the bigger source is quite a distance from that, that's probably okay. But it is complicated. So it's something to be aware of for geological exploration. In Eastern Egypt, it's not known to geologists. It's not known to archaeologists either. They believe that that's where the cobalt was coming from, but there's no actual geological source that's been found yet, which is both a good and a bad thing. It's a big region to explore, But yeah, it's also not been banned to foreigners. Egypt isn't, it's unclear if it would be the right place to be looking, but politically wise, but it hasn't been banned to foreigners. So it's a little more stable possibly than the Western oases. And because we haven't found the archaeological site yet, it's hard to know what the heritage implications would be. It's hard to know if it would be a massive archaeological site or if it would be they were just picking up stuff or samples off kind of off the surface and going from there. Yeah, and then in Khetri, sorry, it's a well-known copper mine today, so they know it. It is known to geologists, and the area is relatively politically stable, or at least more so on the surface than Egypt is. And heritage sites are something to be aware of, but it's not a mass concern given that it's been actively mined for the last 2,000 years anyways. The main concern with Khetri is that since it is so well known, why aren't they mining cobalt already? There's some questions on, was the cobalt heavily exploited in antiquity so that it's a bit depleted now? If the cobalt source is near Khetri, but not actually near where the copper mine itself is, and some new exploration needs to take place. Or if they're just not choosing to mine it for some reason, and why that could be. So while it's viable, the source is also cobaltite, which is not the most ideal ore to be exploiting because of the arsenic levels. And that was an issue in the past. That's still an issue today on how to safely remove the cobalt from an ore that has high arsenic levels in it. So yeah, that's kind of in sum. So to conclude everything, it's clear that chemical analysis of archaeological artifacts combined with careful research can help locate geological materials. 4 areas were identified, which were in Germany, Egypt, and India. And these initial locations could yield detailed information on cobalt if they're cross-referenced, especially with archaeological research, data projection models, and geological research. I personally think that these kinds of projects have huge scope for future work. I think that archaeology, in this context, one of our biggest shortcomings is that we don't kind of communicate with geologists on it. We don't initiate that collaboration. And I think that there's a lot of, well, we can't find the source. Oh, well, we know it might have come from that area. Whereas I think if you could create kind of a collaborative project on it, you could start to really pin down origin materials and sources, which would be great. There's also a lot of archaeological research remaining that would facilitate our knowledge of cobalt as a material throughout time. There's thousands of artifacts worldwide that contain cobalt that could still be tested for their compositional anatomy. And there could also be a really unique opportunity to approach it from a more humanities historical point of view with colonial maps. So the British Empire created an extensive map sources of areas that they thought they could benefit from economically at some point, particularly in the Near East and India. And on many of these maps, they have cobalt. I was looking at a couple of them. Unfortunately, because of the pandemic, I wasn't able to go into the libraries to look at them. So that part of the project got put on pause. The few that I looked at online, there was areas, especially there were one in Jamaica even, that had cobalt on the map, which I thought was really interesting. So at some point, those maps could be a really interesting kind of avenue for the project for cobalt exploration, and also a really interesting intersection of science and arts fields, which I think is important. So overall, studying a geological material such as cobalt throughout history can enlighten our knowledge in the present day, and it could be viable for geological exploration, which could be useful with the global shortage. And it's kind of amazing that cobalt's value has transcended kind of through times and cultures, and it's transitioned from this sought after deep blue material to something that's crucial for our phone batteries. I find that really interesting how the material itself has changed through time, but it still remains really valuable to us today and in our future. Yeah, that's everything. Thank you. Thanks for listening.
Yeah, thank you so much, Helen, for this wonderful presentation. I know for a fact I learned a lot, and I'm sure everyone else did too. So before opening up the floor to questions, I would like to invite every participant to introduce themselves in the chat, which is just available at the bottom left corner of your screen. And if you have a LinkedIn profile, feel free to share it as well in the chat. So I'll just give you a couple of minutes to do that. Hi, Nancy. Hi, Anne. Thank you for joining us. So feel free to keep those going, those introductions, and we can just get started with questions. I know we have a question that was asked a little while back. So Helen, one of the participants would like to know if cobalt is still used in paint.
I believe so. It's less used now. I wanted to look into that more. I was trying not to, when I was doing this project, get too sidetracked by all the little interesting things that I thought were great. But I believe it is still used, but now it's quite expensive because of its value and use in other things in the world, especially batteries. So it's now considered an expensive pigment, but it is still used in paints as far as I'm aware.
Great, thank
you. And it's definitely still used in glass today as well.
Yeah. So everyone else, feel free to drop your questions in the chat, and Helen will be able to answer them. So we have one more question. So you briefly mentioned China and cobalt, like exploration in China. How is that relevant to the rest of the presentation? So how do those two link together?
Yeah, I meant to come back to that, and I got sidetracked by everything else. It's a really good question. I'm actually really glad someone asked that. So there are two provinces in China, in the Gansu and Hebei regions, where they've found cobalt sources. And there's it's Chinese artifacts with ceramics are particularly interesting with the cobalt, because a lot of the ones that have been tested have shown that their cobalt came from Germany, from Erzgebirge, which is fascinating because the cobalt got traded to China, and a lot of these ceramics got traded back to Europe. So there's kind of this continuous movement of objects. But several archaeologists have found that not all of the ceramics match that composition, and their research has discovered sources in northern China. That's complicated because politically China is quite keen to do their own geological exploration and their own archaeological exploration, and it's less open and less viable for kind of other people to look into it in a way that would be really valuable. But it is really important to know that there is other big sources there possibly that haven't really been exploited yet, hopefully. Yeah.
So we have a question about museum artifacts. So do you know if there have been any studies related to cobalt content that have been done on museum artifacts?
Yeah, there's been some. So the first one, the plaque, the Erzgebirge plaque, is a museum artifact itself. It is more complicated to study that because it depends on what type of chemical analysis you're doing. Some analysis like XRF, it depends on what you're like, if you can use a handheld XRF machine or a desktop XRF machine, which is X-ray fluorescence. And for some of them, you have to take a small sample and grind it up and then put that through the machine to get the chemical analysis. So it does happen. People do get access to museum artifacts. It is more rare because you do have to take a part of the object essentially. So it is more complicated, and you need special permission to do it. So, but it does happen. It's less common than artifacts that have been collected from an excavation that aren't going to be displayed in a museum.
Right. So how do you think we are doing as far as recycling cobalt these days? How easy is it to do it, and how are we doing it?
I wish I could answer that question in detail. I don't entirely know. I know that they're trying, I think, well, I just don't want to toss it over to anyone else. My boss is on the call from Petroscience Consultants Inc., and she could answer that question. But I don't know enough about the recycling of the metal itself presently from electric phone batteries or anything. My brain lives in the past.
Right. So I guess we can go back to
Yeah.
the past then. There's another participant who would like to know what type of studies you've been doing in Argentina and in Chile.
Oh yeah, I would love to talk about that. So I'm examining the relationship between colonial and indigenous ceramics. So during the period of Spanish occupation, there's lots of evidence the Spanish imported European ceramics with them. They also created their own locally produced colonial ceramics. And then there's also huge assemblages of indigenous ceramics on 3 sites that I'm looking at. So it's Santa Fe La Vieja and Mendoza, which are both in Argentina, and Valdivia, which is in southern Chile. And I'm basically looking to see if there was a transfer of technology between the two. In my master's, I did kind of a pilot study of just one site at Santa Fe for the same kind of questions. And there's a lot of evidence that after the site was occupied for 90 years, the indigenous populations went back to their traditional pottery forming methods, despite the fact that they were exposed to the pottery wheel. So that's basically what I'm studying. I'm really interested in the fact that there's this kind of evolutionary view of technology and innovation, and this assumption that kind of this dominant culture would bring a new technology and people must accept it because it's better, it works better, it mass produces, etc. But that overlooks the importance of traditional technologies and kind of, especially with something like ceramics and clay, kind of the bodily feel of ceramics and how they're made and how important that is. And I'm hoping to find a trend at my other sites in South America to see that indigenous populations across South America were retaining their traditional methods. I don't know if I'll find that trend. We'll find out. But yeah, that's what I'm studying.
So I have another question that's kind of related. Do you know anything about ceramics that are in other parts of South America, such as Peru, Bolivia, or Colombia?
Not as much. I would like to. My PhD started on October 26th. So I'm about 2 weeks into it. I'm doing my lit review right now. So I am going to continue to expand and read about other areas and how I want to get some more case studies going. But I am very, very new to the PhD.
Yeah. So maybe going back to batteries. So the recycling of batteries is a really big area of work. And the technology that we use for it is continuously evolving. So how would you say that to determine the recycling process? So do you know something like a little bit about the recycling of batteries surrounding cobalt?
Not surrounding cobalt specifically, no. Yeah, like I said, I don't know as much about that part of the area as much as I'd like to.
Sure. So do you know if there are any other elements that are commonly found where cobalt is found, and maybe that are that were used in the past by similar communities and similar societies?
Yeah, so it depends. It's kind of depending where you're looking. So a lot of cobalt artifacts that have been found around Europe and the Mediterranean have aluminum in them as well. And that's often indicative of the fact that their source material might have come from those alum sources in Egypt, because aluminum was another big product in that runoff material. And then arsenic is the other really big one, especially in the later medieval sources and things like that. But it depends, because there's a lot of different cobalt ores that come with a different host of elements with them as well. So cobaltite's a big one that has arsenic in it, but there's lots of others that have nickel and other elements as well. So it's not kind of yeah, a one element fits all type thing. There's a big range.
Sure. So we have time for a few more questions. If anyone else has any more questions that they would like to put in the chat box. I guess I can ask you a question as well. How much have you seen that we continuously keep getting our cobalt from similar sources than in the past, or like do we still get most of our cobalt from the mines that you mentioned that were used historically, or how has that evolved?
So as far as I know right now, cobalt isn't being taken from any of the mines that I mentioned historically. Yeah, the biggest source in the world right now is still in the DRC, and that's where there's been a lot of attention and focus and a lot of issues with as well. There's another source in Morocco that's being exploited as far as I know. That one is a cobaltite arsenic source. So they've had issues there with trying to figure out how to safely separate the materials and keep their workers safe. But that's, as far as I know, not really a historical source that's well known. Yeah, the ones that I find it really interesting that there's these sources that are, I didn't discover these sources. They're in the archaeological literature already, and they haven't really been looked at from a present day geological exploration point of view. So yeah, I find that interesting.
Yeah, definitely. So if we don't have any more questions, we can actually move on to the closing part of this presentation. So first off, I'd like to thank Helen for her time. Thank you so much for your presentation. And I'd also like to thank all the participants for coming and attending this presentation. So we do have a post-presentation survey that is going to be sent by email to all of you. So please fill that out just to give us some feedback, how we can improve, and what parts of this presentation you liked. And we also have a Zoom poll if you would rather answer here instead of answering through the survey. So it should pop up on your screen, and you can just click one of the options just to give us some feedback.
While we're waiting for the poll to be answered, there's one more question, Adele.
Oh, yeah, I see. So, Helen, is it normal for a petro company to employ archaeologists?
No, not normal at all, actually. Yeah, it was an exciting opportunity that came up with some connections I have. There's PetroScience they've evolved from being a kind of a petrography consultancy inc to more of they're interested in geological topics, from technology to sustainability to innovation, and kind of how it all affects the world today, climate change, etc. And yeah, there was just the talk that I saw in December. Somebody who works for PetroScience who gave that talk. He works for a company called Cobalt, which does cobalt exploration. So we kind of got talking after the talk and basically just developed this project and this idea to look into it from an archaeological point of view. So yeah, as far as I know, a lot of petrology or geology companies don't often hire archaeologists. I think it's a really interesting way to look at things, and I'm biased, but I think it's important to intersect sciences and arts and kind of look at it from a interdisciplinary point of view. But yeah.
Yeah, absolutely. There's been a surge in interdisciplinary research, and I think it's been really great. It's such a good thing to combine more than one profession,
Yeah, absolutely.
Yeah. So we also have another question in the chat, which is more for participants. If you have any more feedback or any more comments that you'd like to share, please do so in the chat. And as you can see, we've also had Christine share the poll results. So thank you all for those very positive reviews. Yeah, so if any of you would like to share in the chat what you found helpful from the talk or what you found interesting, that'd be great. I would also like to remind everyone that we have one of these brown bag sessions every week, so it usually happens on Wednesdays, but this week, just because of Remembrance Day, we moved it to Thursday. So next Wednesday on November 18th, we have another brown bag, which is concerning job hunting strategies for students pursuing jobs away from the bench. So it's concerning leaving the lab jobs and going, I guess, a little bit further in job search. So if any of you are interested in that, please join us next week. And yeah, you're welcome to stick around and add some comments, or if you guys have any other questions, and or maybe take a minute to fill out the survey.
Great. So we're officially done with this event. Thank you so much for your feedback. Helen, thank you so much for this presentation.
You're welcome. Thanks for having me.
So just, Adele, if you'd want to read some of the comments.
Sure. So we've got a lot of people thanking you in the chat, Helen. Yeah, so we have some feedback saying that they really enjoyed the intersection of coordination, chemistry, crafting, and exploration. And we actually have another comment also that says they particularly like the interdisciplinary nature of this talk. So as we were saying, I think that's something that's been a lot more common recently, and it's really great to kind of see that happen firsthand, or see you talk about your firsthand experience in that. Yeah, so very interesting to learn about the intersection of art, science, and history. And yeah, it's great to hear a different approach at looking for sources of cobalt, which is great to learn about. So we've had some people who like that. Yeah, so thank you all for coming. And please join us next week for our next session. All right.
Good night.
Goodbye, everyone.
Thank you, everyone.
And you're welcome to stay. Hi, Maria. Thank you for, I see you again. Yeah, wow.
That was great, Helen.
Thank you.
Very good.
Maria, you want to say something? We can't hear you. You're muted.
Hello, Helen. I was the person with the questions about South America. I am originally from Colombia, and I have been doing collaboration in other aspects with mummies and genetics. But I know somebody who he doesn't live in Colombia, but he's one of his projects of research is with ceramics in Colombia, especially in the north of Colombia. But any chance, if you want to have a connection with this person, let me know, and I can approach him to see if if you need this connection. Yeah.
Yeah, that would be fantastic.
Maria, would you want to drop your email address in the chat box so Helen can contact you?
But my nickname is Vicky, but I will put the whole thing.
I keep forgetting Vicky.
Okay.
I'm just reading it off.
I appeared, okay. So my email is...
Maria and I first connected with a SCWIST walk sometime in August. We did this long walk from Aquatic Center to Sunset, to what is this? Beach? Sunset Beach, right? Yeah.
Yeah, exactly. Yeah. By the way, I was part of, the leader person of the studies of Cobalt and Sinchi, the Canadian ice mines, and we did studies of organic and inorganic elements in the lungs.
Oh, cool.
Well, I can send you later on the paper.
Yeah, please do.
Okay, and this is, call me Vicky Mansar. Yeah?
Yeah, definitely.
Let me
I'll send
put,
you an email.
Thank you, Vicky.
okay, bye-bye.
Bye.
Thank you.
And
And let me
see you
see,
in other events.
let me see. Oh, doesn't go further. I tried to,
Oh, I haven't done anything.
no, because doesn't go further. Did you get the email?
Did I get it? I'm still sharing my screen, so I can't see it yet, but I'm sure I've got it.
No. No, because here it doesn't look like it went there. Well, it's vmonsalve at pathology.ubc.ca. Can you see in the screen or in the chat?
No.
No, it's written there, but doesn't allow to go further.
If I can't get it now, I'll email Christine as well. And she can pass on your information.
Perfect. Okay, bye-bye. Thank you.
Bye-bye. Oh, there it is.
Thank you,
yeah. Thank you, Ronel. Thanks, Ronel. Okay. Ronel typed it in.
Okay.
Yeah.
Thank you.
Perfect. Thank you to also Christina for allowing this.
Vicky.
Thank you.
Oh, no.
Okay, bye.
Welcome. You're always welcome.
Bye-bye. Thank you.
Bye-bye.
Okay, stop recording so that I can go on and on about how fascinating this was.
No, we have to record this because this is positive feedback.
This was amazing, Helen.
This is recorded for positive feedback.
I have not been riveted. I just wanted you to go on and on.
Yeah.
Thank you.
I didn't know what to expect. I mean, the whole title of the talk was intriguing, cobalt and archaeology. So I thought, well, I'll definitely drop in and give it a go and see what it's about. And right from your first slide, I was like, okay. And then your second slide, I was like, oh, this is even better. It makes
I'm really glad you enjoyed it.
No, absolutely.
Ronella was actually thinking we should have Helen back next year. It's a 40th anniversary, and it's a great. Most of our topics have been health, life sciences, tech.
Yeah.
So this is just a new field that we're discovering.
New and interesting. Yeah.
Oh, and so I understand. Maybe I don't remember correctly, but have you been a SCWIST member for quite some time?
Well, sort of. The first time I participated in SCWIST events would have been in the mid-90s, 94 maybe, 95, yeah. But I have not been active. I've been on the mailing list for years, and I've done a couple of the XX events at Science World, the mentoring events. I used to go to those events and participate. Yeah. And now I have two daughters who are both scientists, so it's great.
Oh, and,
yay!
And aside from Helen, what's your
I
other
was gonna say, in
field?
case you didn't get, she's my mom.
My other daughter has a PhD in geomicrobiology.
Oh, then we should have her for a brown bag.
She would be great, actually.
She should.
She has her own interesting story to tell. Yeah.
And then we're gonna make up an 40th anniversary award for what do you call this? 2 generations of scientists, 3 generations of scientists, the longest generations of scientists. Yeah, thank you so much. We'd love to know more about you as well, Anne, and your work. So we'll keep in touch.
Yeah, I probably have something I could do for a brown bag if I put my head to it.
Yeah.
It'd be fun. Yeah. The whole connection from the earth to sustainability and metals and where we find stuff is kind of entertaining. Yeah.
What I want, one thing I'm thinking of next is that we should probably have an interview session with all the 3 of you. And see how all your sciences and your projects intersect, and what actually how your daughters have seen you as a role model.
Yes.
And Lord, that would be interesting.
Okay, we have your
It's my dream to publish a paper together.
I don't know what they think. Yeah, exactly. Yeah.
And of course, we'd like to thank Adele. This is Adele just joined SCWIST as a volunteer and a very, very new member, and I roped her in last week.
Excellent.
I think just not even last week, even just a few days ago. would you want to be a brown bag host? And thank you, Adele, for just saying yes.
Thank you so
You're
much.
an amazing host.
Yeah,
You did
I
a
actually
great
thought,
job.
wow, she's so poised. Because if I did the moderating, the hosting, I'm jumping
calm.
around and laughing. But you're so poised and so professional that you've actually set another benchmark for us. Okay.
Oh, thank
Forward,
you. To hear.
more professional, and thank you so much, Adele. And we hope you'll host future events, especially starting next year.
Yeah.
Thank you so much for the opportunity.
I had one quick question about the brown bags. Have you ever tried just having a really short, like 2 or 3 minute breakout rooms, just so people can say hello to each other?
You know what? We haven't done that, but I increasingly have been hearing requests to at least after the presentation have small breakout rooms, so participants can unpack what they've learned.
Right.
Yeah.
And they can just speak to each other, and then the questions will flow. Yeah.
So you mean to say, like, just after the talk, we'll break out?
It could be just after the talk, yeah.
And we come back for the general Q&A.
2 or 3 minutes is probably enough, or less than 5 anyway. I don't think you need a lot, but it just would make it less, just like, because we all are online listening to a lot of talks right now. It would just be a little bit more personal, and you could say hi to somebody, and
join us.
Random breakout.
Join us next week, because next week the presentation will be very short. Our speaker can just make it for 30 minutes lunch break. But if you're going to join us the following week, we'll definitely do the the breakout sessions. Although next week we can actually do a longer breakout session, because we will try that next week. Yes, we will try that next week. Thank you so much for your suggestion.
Okay. Yeah, it was great. It was great to reconnect with SCWIST. Thank
you. Yeah, that's the purpose of all these brown bags. And definitely we'll invite you both back, 3 of you back for an interview. That would be fantastic. And
Okay. Thank you. I'm going to log off. Okay. Bye-bye.
Take care. Bye. Thank you. Bye-bye. Helen and Adele, I'd like to introduce you to a very key SCWIST board member. And I'm glad, Ronald, that you came, because she's usually the tech person, but she's like, I'm tired of doing all your tech. That's kidding.
Never said that.
I just felt I kept imposing. But yeah, Ronald is amazing. She's also on the board of directors, and secretary now, plus co-director for affiliates. Yeah, we work very well together. Right, Ronell?
Yes, we do.
We have amazing people, amazing people. So we hope, Helen, that this has sparked your interest to become more involved from the UK. Yeah. You can have a SCWIST UK chapter. Yeah.
Well, if I get my older sister involved, she's in Germany right now, so we can have a whole European group of us.
Oh, SCWIST EU, cool. And Adele, welcome. You're the newest. You're newer than Helen as a member, just days old. So welcome. We hope you've seen how interesting the topics are for the brown bags, and how we have really experts within the group. So jump right in again. We have many events. So just question, Adele, how do you find, what's your feedback? How can we improve?
I think it was really great. I really liked Helen's presentation. I thought it was really interesting. I do agree with and that I think breakout rooms would probably work well. And probably give members a chance to connect and to I guess form maybe some more personal connections, which I'm sure is on everyone's mind now that everything is remote. So I really like that suggestion as well.
We'll start doing that next week. I forgot, because I can't see Nasira's camera. Nasira, you want to say hi? Hi, Nasira, are you there?
She had a problem with her audio not joining for quite some time.
Right.
So I'm not sure whether she's actually joined or not.
Okay. Helen, feedback?
I thought it was pretty good. I mean, I really enjoyed it. I have no comments. I think the breakout room is a good idea to get to chat to people. To kind of just
Okay.
What everyone else has said, really.
So you're gonna join us in the future brown bags and check us out with the breakout rooms. Okay, I'll let you go. Have a good evening.
Thank you, ladies.
Well. Okay, bye bye.
Thank you so much for having me.
That was great. Bye.
Thank you for having me. Bye.
Yeah, thank you so much. Bye.